I haven't even started looking at next week's stuff, but
Yeah, me neither.
for the
But I
most
guess
part, all I do is look to see if we posted. What was that?
I'm saying that we can just walk through it. I guess just go through it.
Yeah.
Alrighty. Let me pull up that page.
But first, we have to do the group quiz for this last week,
Okay, let's do it.
since that's due in an hour and a half.
Yeah, I'm gonna pull that up right now.
Okay. Bring this over here, that over there. Rearrange my computer a little bit.
Okay.
All right.
All right, I've got it up now.
Okay. So have you looked through the group? I can't speak. The group quiz.
That's all right. I looked at it. I think a couple days ago. And saw and it looked relatively. There were some confusing things, but I just didn't look into it that much. So, but
Okay.
I do have some notes on it just because I had some time on Saturday to write it down and try to see if I could figure it out on my way home. But we'll see.
Okay. I was able to. I've worked my way through question 1 and question 4.
Okay.
I'm not very good at identities.
Okay, no
And
worries.
so question 2 and question 3 are like reading Greek to me.
Okay, no worries.
That's where I'll be spending. Well, we'll have to spend most of our time.
What I'm reading in question 1 right now, it seems like I did use the Pythagorean theorem. I don't know if it's that simple or not, but it just says that if we're going west and we're going north, then we're trying to find the resultant vector. Is that correct?
Right.
So in a way, we're just finding the hypotenuse?
In a way, yes. And you wind up using Pythagorean theorem.
Okay.
So.
Okay, so it seems like it'd be pretty simple then for the resultant vector, but then we have to find the angle. Is that what it means by direction then?
Yeah, you need to find the resultant angle and then the magnitude of the result. So how fast are you actually traveling and in what direction? We happen to know that it's going to be northwest, but then like the specifics you have to work out.
Alrighty.
So I first drew a little picture showing the two vectors. You know, you're going west and then there's a vector going north.
Right.
And then the resultant, the magnitude, you use the magnitude formula that they give us, which is the whole, let me see if I can find it. I've written all over my notes. Where is it? Oh, you know what? Some vectors I'm looking at polar. So it's the value of the magnitude is the square root of, the square root of v1 squared plus v2 squared.
Okay, perfect.
Right?
Well, it would be x squared plus y squared.
Yeah, so you multiply the two vectors together, and you wind up walking away with just the value of each vector. So you have the 3 miles an hour and then the 6.2.
Yeah.
And then you plug that into your formula. So it's square root of 3 squared plus 6.2 squared.
But yeah, so I got a 6.88.
Yeah.
6.9.
So it rounds up to 6.9. 6.88.
Okay, perfect.
6.9. And then
that would be the speed that you're going in that direction then.
Yeah, that's your speed. And then you can use Pythagorean's theorem to double check it. Like you pointed out, we really could have just used Pythagorean's theorem for all of this.
Okay. And then I got the angle being 4.2.
The angle?
Yeah.
How did you get 4.3?
64.2. So I did the inverse tan 6.2 over 3 to get that.
Oh, no, that's right. That is, why do I have 115? Oh, because it's a bearing. So 64.2 is correct within the triangle, but
Okay,
then you have to have the compass bearing.
I see. All right. Oh, I see.
So they want the,
So 180.
so winds up being 180 minus 64
Okay, perfect. All right, that works
is
perfect.
your compass bearing. But you're right on. That was perfect.
Cool. All right, so we can. I think those are pretty straightforward. We can go to number 2.
Yeah.
Okay, so
Please
yeah,
tell me
I had a
how to
little
do
bit.
this.
Yeah, I had a little trouble with it too, but I think I figured it out. And if you want to check me, if it seems right,
Okay.
so we have r equals 10 over
Over 3 sine of theta
3
minus
sine.
7 cosine of theta.
That's right. So we have x squared plus y squared equals r squared.
Okay.
Let me pull that up real quick. So x squared. So since it's just r and we're just trying to get circular coordinates, we can just put that as x plus y. If it's
Just
true, so
change
r
R
squared.
to Y.
Yeah, so if r squared equals x squared plus y squared, then r equals x plus y.
Okay.
So we just square rooted both sides of r.
You're just substituting the value. Okay.
Yeah. And so
So
since now
for
we
R,
didn't,
you have x plus y on the
yeah,
left side.
so instead of r, we substitute r with x plus y. So now we multiply both sides by 3 sine theta minus 7 cosine theta.
Okay.
Cosine theta.
Which is a quadratic equation.
Exactly. Yeah, and that's what we're looking for. So now we'll get oh man, how do we do this? Yeah, so now we have oh, you know what? No. So we don't make r x plus y just yet.
Okay.
We're going to keep r as it is, but we're still going to multiply both sides by 3 sine theta minus 7 cosine theta.
Okay.
And then we're going to distribute the r into 3 sine theta and cosine theta equals 10.
That makes sense.
And so it's 3r sine theta minus 7r cosine theta equals 10. So now we can make that 3y minus 7x equals 10. Since r sine theta equals y,
That's true. Okay.
and r cosine theta equals x, and so we'll just subtract the 10 into the other side, and then we have our equation, our rectangular equation.
Do you make the equation equal to 0, or do you have to solve for y?
Yeah, I've seen. Let me double check that. We have one actually.
We do have poor connection. I think you solve for y.
We solve for y. Okay.
I think so. Because when you graph an equation, it's y equals mx plus b.
That's true.
Right.
So I guess now we can.
Right. And now it's
That's
super
all.
easy to solve for y.
Yeah.
I could write it down both ways and just say, because it's 3y minus 7x minus 10 equals 0, or y equals 7x plus 10. Sorry, 3y. equals 7x plus 10. Where y is 7/3 x plus 10/3.
Yeah, that works. But it's either, I think you're right, just solving for y, right? Making that into an equation that solves for y. Okay. Does that seem about right?
What is that?
Does that seem right enough to put down? Do you feel comfortable with that? Or?
I think so.
Okay.
It seems to me that we would solve for y.
Okay. All right. So we can move on to number 3. This one might be a little more challenging. Let me see here. Nine y over x 2. So right off the bat, I think we can just make the left side equal to r squared.
Yes, you could.
And then so that leaves us with r squared equals 9 y over x squared. And we can go ahead and substitute y and x for sine theta and cosine theta. So in the end, it would be r squared equals 9 sine theta over cosine theta, which is tangent theta.
Right.
So r squared equals 9 tangent theta squared.
And you could just take the square root.
Yeah.
Because for a polar equation, all you do is solve for r, right?
That's right. So
Oh.
we can just square root both sides.
It would just be 3 tan theta.
Theta.
Does that seem right?
Would we square root the 9? Oh well, yeah, we square root both sides completely, huh? Yeah. 3 tan theta. Does that seem too simple, or was that? Did it make sense? I think that's. Well, it wasn't as challenging as I thought, but I think it kind of worries me a bit. But
That it was too easy.
yeah, but I mean that's what it looks right. Yeah, I mean I think that's right.
I think it's right too.
R squared 9.
I don't see anything wrong with it.
Okay.
Okay. And then for number 4,
Uh-huh.
it says the ordered pair in a polar coordinate names a single point, but the coordinate is not unique. Name 2 other polar coordinates that are located in the same spot. They're just asking for a terminal angle.
Okay.
So the first week we were learning about the coterminals.
Yeah.
And I got online and looked up a little help. It's all just coterminal polar coordinates.
Okay.
And for this particular one, you could write an unlimited number of coordinates.
Oh, really?
It's just, well, you could do, so it's 4 and 4 pi over 3. You could do -4, 4 pi over 3, because all the 4 does is designate the radius.
Oh, I see. Yeah, that's right. Oh, okay. That makes sense.
And since there's no real negative on a polar coordinate plane,
That's true. Okay.
it's positive.
So one of the other polar coordinates is definitely -4.
So it can share with -2 pi 3, 2
Okay.
pi over 3. Same, so it's +4, -2 pi over 3. Continue around the circle.
Okay.
So 4 pi thirds, and then, what is it, 8 pi thirds? You would just double it. 7, 8.
But just still keeping
10,
-4, 4. Is that
13.
right?
-4 what?
You would just keep 4 as long as it's on that on that 4 or -4, it wouldn't matter.
You would keep 4.
Okay.
So that one was fairly easy.
Awesome.
Yeah.
All right.
Well, that went a lot faster than I thought it would.
That's true. That's
Okay.
very true.
Let me stop this
All
one
right,
real fast, and then we'll start it into next week.
All right. Do you want to go ahead and submit it? I'll give you like 2 minutes to submit it, and then we can just not worry about the 11 o'clock deadline.
Yeah, I agree.
Okay.
That works perfectly for me.
All right. I'll see you in a bit.
Yep. See you in a minute.